Hi there, this is Mrs. Hammer, and I'm joined today by Mrs. Guzman, another pre-AP chemistry teacher here at Richardson High School. And today we're going to be giving you an overview of this ion sheet that you probably have received a copy of. Basically, these are the ions that you need to commit to memory to be successful in pre-AP chemistry or AP chemistry. And just like in a foreign language, you need to memorize certain words and terms that are essential for communication. These are our words and terms that are essential for communicating in chemistry. So that's why we commit them to memory so that you and I are speaking the same language. So the first thing we need to talk about is these two terms up here, cation and anion. So a cation is a positive ion, and an example of an atom that would form a positive ion is sodium. So first we're going to focus on the sodium atom, and if you check out the periodic table, it is number 11 on the periodic table, and we know that means it has 11 protons and 11 electrons. So overall, 11 positives and 11 negatives means that sodium is neutral, okay? But when sodium becomes an ion, it actually has a +1 charge. We'll talk a lot throughout the year about why sodium specifically forms +1, but overall, right now, let's just learn that it has that +1 charge. But what does that mean? It's still sodium, so it still has 11 protons. That's its identity, but it lost an electron, okay? So if we add that up, 11 positive, so positive 11 minus 10 is +1. So sodium is a positive charged ion. So again, sodium is a cation. And let's give an example of an anion now. Fluorine, the atom, is going to form a negative ion, fluoride. And that's how it's listed on your ion sheet, as fluoride. Fluorine, the atom, is number 9. So it has 9 protons and 9 electrons. So again, like all atoms, it's neutral. The ion still is fluorine, so it still has 9 protons, but fluorine actually gains an electron. So it gains 1 electron and now has 10. So if you take that +9 and -10, we see that's where the overall -1 charge comes from. So that's an overview of what a cation and an anion is. So we're going to look at the first section of ions on your ion chart. These are called the monatomic cations and anions, specifically the common ones. And what we're going to see is that there's some simple trends on the periodic table. For instance, for learning that all of those are +1, that all of those are +2. Let's see, another big important group over here is that these are all -1, these are -2, and these are -3. So there's some trends. So let's go to the periodic table and look at this. What I want you to first look at is this group 1 right here. Okay, everything here in this group 1 forms a +1 ion. So lithium, sodium, potassium, rubidium, cesium, and francium, all of those would be listed here as a +1 ion. It stops eventually after cesium because francium is just not very common, but in theory, francium would also have a +1 charge because it's in that same column on the periodic table. Now, the next little grouping that we see has the same charge as beryllium, magnesium, calcium, and barium. And guess what? If you look on the periodic table, I'm going to kind of do this in a different color. All of those are also, again, in the same group. So everything in group 2 forms a +2 charge. So that's another group that if you just, memorize that everything in that group has the same charge, it's +2. I always tell my students, 1, 2, skip a few. We're going to skip these right here for this trend, okay? This column right here, we just kind of continue on. That was +1, +2, so this one over here is +3. So the one that you'll see on your ion sheet for being +3 is aluminum, but these underneath it also tend to form that +3 ion. So now we're going to, that kind of takes care of that positive side. Now we're going to look at the ones that form negative charges, okay? The first little grouping is the negative ones, okay? Fluorine, chlorine, bromine, iodide all form ions called fluoride, chloride, bromide, and iodide. So if we look at the periodic table, we see, I'm going to get my highlighter back, they are again all in the same column. These are all called the halogens, okay? And we see that they all form the same ion charge. All of these are -1. Okay, so again, it's just a trend for what they form. They all form the same ion. And just like when we started on the left side and worked in, the charges increased, the magnitude increased, the same thing happens over here. So if this column is -1, the next column over is -2, and the next column over is -3. So we'll see that oxide and sulfide are -2, and then nitride and phosphide are -3. So that kind of takes care of that group, and that group. It is worth noting that hydride exists. Now notice that hydrogen also had a +1 possible charge. Hydrogen's kind of special. It can kind of go either way. It can become positive or negative. If it becomes positive, it maintains its name, just like all the other positives maintained their name. If it forms a negative ion, look at the ending. It ends in "ide," just like all the other negative ions formed an "ide" ion in their name. So hydrogen can form positive or -1, and the naming system is consistent with all the other elements. If it's a positive, it keeps its name. If it's a negative, it switches the suffix to "ide." So those are called, again, just our monatomic cations and anions. And the key thing you want to remember about this section of your ion sheet is that you can predict the charge by the column on the periodic table. So now we're going to move on and we're going to talk about the next section on your ion sheet.
Okay guys, it's Mrs. Guzman here. I just wanted to talk to you guys for a second about these things called the transition metals. Okay, transition metals, as that implies, is that they change. Okay, unlike the other ones that Miss Hammer just spoke to you about, they don't have fixed charges except for a couple of them, which I would like to note. Okay, so ones that do not transition are hold. One second, let me find this. Oh, sorry. Are these guys right here. We have silver right here. It is number 1. If you're an Aggies fan, you can think about it as Aggies are number 1, so that's the number 1 charge. And you can see that these have these little symbols right here because they are in the category of transition metals, but they do not transition. Okay, then we have cadmium right here and zinc, and they have a +2. Okay, right next to it's kind of aluminum, so I just think that it goes 1, 2, 3. It helps me find my bearing. Now these other guys, they're kind of mysterious, okay? And so sometimes if they're mysterious, we need something to guide us. And the guide right here is going to be this Roman numeral right here, okay? And just a quick review of Roman numerals. If you have just an I, that means 1. And if you have 2 I's, that's 2. 3 I's, that's 3, and then an IB, that's 4. Okay, so when you have those, that tells you what the charge is on those little mystery metals or transition metals. So if I have something that says iron 3, well, that tells me that the charge is in fact a +3. Iron 2 has a +2 charge. Copper 2 right here has a +2. Okay, the only thing that gets a little wonky is this guy right here, mercury. Okay, mercury, right here, these guys, sorry, I'm not so good at this, a little bit strange. Mercury 2, kind of normal. It tells you Mercury 2 has a +2 charge. Okay, but Mercury 1 is diatomic. It means that it is stuck together to another Mercury like a Siamese twin. So Mercury 1, the two guys kind of stuck together, each of which have a +1 charge. So overall, there's 2 of them. So I'm going to put a little 2 to remind me of that. And then if I have +1 and +1, the whole thing has a +2. Okay? Now, note that these have little crosses next to them, and that is not included in the name. That is just to note that these are transition metals that, in fact, do not transition. Okay? All right.
All right, so we're going to go back to our ion sheet, and the third section on the ion sheet is called the polyatomic ions. And if you glance through this section, you'll see that all the ions look a little bit more complicated. If you think about that term polyatomic, what it actually, ooh, hang on. What polyatomic actually means, poly means many, and atom, of course, means atom. So these are multi-atom ions, so they all have more than one atom in them. So that's what a polyatomic ion is. Um, the first thing to note is that some of them are positive. We'll talk about, there's only two of them, so we'll talk about them real quick. Mercury 1 is, it's kind of confusing because it's called Mercury 1, but it says Hg2 plus 2. So it's basically two Mercury 1s stuck together. They always exist as a pair. So if you kind of sum it all up, it's Mercury, there's two of them, and it has a plus 2 charge. So that's Mercury 1. The other only positive polyatomic ion is ammonium. It's very similar to the compound ammonia, which is NH3, but it's the ion NH4. All right, so the next thing I want to show you is that there are some compounds here, not compounds, combinations of ions that have ites or eights. Ites or eights. Phosphate and phosphite are another combination. Here's one, chlorate, chlorate. So what you might notice is that the 8 has one extra oxygen over the ite. So like nitrate has 3 oxygens, nitrite has 2. Sulfate has 4, sulfite has 3. But how are you supposed to remember that? How are you supposed to remember that like nitrate and sulfate, they have the same suffix, but they have a different number of oxygens? Same thing down here. Chlorate has 3 oxygens. No, yes, chlorate has 3 oxygens. So how are you supposed to know which, we call them the 8 ions, they end in 8. How are you supposed to know which 8 ions have a certain number of oxygens? So we're going to learn again a little trick about the periodic table to figure this out.
Okay, so back to Mrs. Guzman. I just want to talk to you guys about this thing called the elbow. The thing about the elbow is that if the beginning of the polyatomic originates in this little elbow, which I'm having trouble shading, actually we can put it right there. If it originates right there, I like to call this the big fat elbow. And the reason why I like to call it that is because it starts at B and it goes to F and then it comes down here to AT. So it's my big fat elbow. Now here's the deal with the big fat elbow, okay? That, when you look at that, I always think about, this means that it ate 3 oxygens. So when we look at something like nitrate, okay, nitrate, if you look on your chart, nitrate, obviously the beginning of that is going to be nitrogen. And I'm going to find my bearings. I'm going to see that nitrogen kind of originates in that elbow, right? So that means that nitrogen has 3 oxygens attached to it, okay? Now, notice that it has a -1 charge, okay? If I look over at something like chlorate, okay? Chlorate right here, okay? I know the origin of that is going to be chlorine, okay? And I can tell if this 8 is going to have 3 oxygens or 4 by looking up. I notice that chlorine does originate in that elbow, and so I know that it has a -3 charge. I'm sorry, it has 3 oxygens and a -1 charge, okay? Let me go over to bromate, which is not on there, but if we were to look at bromate, we would see that bromate originates in the elbow, which means it has 3 oxygens versus 4, and that one also has a -1 charge, okay? So you can notice some patterns. So from nitrogen on in the elbow, if it ends in ATE, it's going to have a -1 charge. So I'm going to try to kind of shade that here. These guys, all of those 8s, they have 3 oxygens and a -1 charge. So nitrate, chlorate, bromate, iodate, any of those. Okay? Now, the reason why it's important to know that is because some of the 8s do not have that. Some of them have 4 oxygens. So if you look at something like phosphate, okay, so if we were to find phosphate on here, oh my goodness gracious, here it is. Okay, phosphate is not in the elbow. It is out of the elbow. So it has 4 of these guys, okay? And so We get 4 oxygens in that 8 state. Now this one, phosphate, actually kind of takes on the same charge as phosphorus, which is -3. Kind of helps me remember that. Sulfate, if we look at sulfate, okay, sulfate has a -2 charge, okay, and I noticed that the origin of that is sulfur, and it ate 4 oxygens because sulfur did not originate inside the elbow, okay. So I guess the take-home message is if it originates, the very first part of that ion originates in the elbow, it's going to have 3 oxygens, and majority of them are going to have a -1 charge. If it originates outside of the elbow, then it will have 4 oxygens in that 8 state. Okay?
All right, so we just have a few more things to talk about in relation to polyatomics. I'm gonna like kind of circle this whole little section right here with chlorine polyatomic ions. If you notice this little series, they all have a -1 charge. They all have chlorine and they all have a certain amount of oxygens, okay? So a trend that we're going to see is that if you look at the 8 ion, you can figure out 3 other ions from it. So if we think about chlorate, okay, I'm going to just call it 8. Okay, chlorate. It has 3 oxygens because, as Miss Guzman showed us, it's in the elbow. Okay, if you lose an oxygen from chlorate, so it becomes ClO2, I mentioned earlier that if you lose an oxygen, the 8 turns into ite. So this one becomes chlorite. And if you lose even another oxygen and it becomes just ClO minus, you take the name chlorite and you give it the prefix hypo. Hypo means low, so it's the lowest amount of oxygen in the ion series. So it's hypochlorite. So 8 turns into ite when you lose an oxygen, and ite turns into hypoite when you lose another oxygen. So the 8 has helped us figure out 2 other ions. 8 can help us figure out 1 more. If we go with more oxygens, it becomes ClO4 minus, and you put the prefix per on it. I think of it as like hyper means more than, okay? So perchlorate means that it has more oxygens than the regular 8 did, okay? So I'm going to pick a different ion now that ends in 8, and we're going to be able to, again, predict all of the other ions that are related to it, okay? So I'm going to pick, I'll pick one that's kind of different. I'll pick permanganate, okay? So permanganate is MnO4. So MnO4 minus is permanganate. Now this one's actually a little bit different because it's starting with the per8 ion. Okay, there should be an A there. So we can't increase further than that. The per is the biggest one. So if we take away an oxygen, it becomes MnO3 minus. And losing the per is the same as losing 1 oxygen. So this just becomes manganate. Okay? All right, so now we're kind of at our like reference point ion, the 8. If we take away another oxygen, it's going to become an MnO2 minus, and taking away an oxygen from an 8, remember, turns it into an ite. So this would be manganite. And then we can go 1 more. Taking away 1 more oxygen becomes MnO minus, and remember that it gets that prefix that means the lowest. So it turns into hypomanganite. Hypomanganite. So manganite. Trying to spell here, guys. Hypomanganite. So you can really take any ion that ends in like 8 or ite, and you can figure out a series of 4 ions that are all related but have a different number of oxygens. The last thing that I want to mention to you is there's a couple ions here that have a hydrogen attached to them. So like hydrogen phosphate or hydrogen carbonate, okay? The main idea here is that you are taking an ion that you would have memorized already, and you're adding on a hydrogen ion, a positive hydrogen ion. So hydrogen carbonate is literally like you're taking the hydrogen ion and the carbonate ion, which is CO3 minus 2, and adding it all together. So the atoms are HCO3, and the charges are that positive and that minus 2. So the overall charge is -1. So this is hydrogen carbonate. You're literally just adding on that positive hydrogen. So it adds a hydrogen to the front of the formula, and the charge goes up by 1. So the other example that we see is hydrogen phosphate. So we take our regular phosphate, which is PO4 minus 3, okay? We're going to add on a hydrogen, and the charge changes from -3 to -2. So that's our hydrogen phosphate. And one more that you might see it looks kind of similar is dihydrogen phosphate. Well, you should know that di means 2, so that's adding on 2 hydrogens, and the charge is going to go up by 2. So here's your phosphate again, PO4 minus 3. If you add 2 hydrogens onto the front and they're both positive, the charge is going to increase by 2, so it becomes -1. So that's the last trend or tip that we have for helping you memorize these ions. The rest of them you might notice are just kind of like oddballs, dichromate, chromate, peroxide, oxalate, thiosulfate. There's a thiocyanate up here. So there are a handful of these that you simply need to commit to memory. Creating flashcards is going to help you do this, and dedicating time to it is the other thing that's going to help you. There's really not much else that you can do to learn these except spend some time with them. So we hope that this was helpful to show you some tips and tricks to memorize your ions faster. And as always, if you have any questions about ions, feel free to leave a comment or ask your teacher. We really appreciate you watching. Hope you have a good day.